When discussing tank armor in World War II, no nation reshaped armored warfare as profoundly as the Soviet Union. While other countries pursued thicker steel, complex designs, or incremental upgrades, Soviet engineers approached the problem from a different angle. Their focus was not on perfection, but on balance. Soviet tank armor was designed to be effective, producible in massive numbers, and survivable under the brutal realities of total war. At the outbreak of World War II, Soviet tank armor was uneven and inconsistent. Early models such as the T-26 and BT series featured thin, mostly vertical armor plates that reflected interwar design philosophies. These tanks were lightly protected and vulnerable to modern anti-tank weapons. Their armor was sufficient against small arms fire and shell fragments, but it offered little resistance against dedicated anti-tank guns. When Germany invaded the Soviet Union in 1941, these weaknesses were brutally exposed. The shock of Operation Barbarossa forced a radical transformation in Soviet armor philosophy. Sloped armor became the defining feature of Soviet tank protection. By angling armor plates rather than relying on sheer thickness, Soviet designers dramatically increased effective protection without adding excessive weight. A sloped plate forced incoming shells to travel through more material and increased the likelihood of ricochets. This approach allowed the T-34 to resist German anti-tank weapons far more effectively than its thickness figures suggested. Equally important was how Soviet armor was manufactured. Instead of using highly refined, expensive alloys, Soviet factories relied on simpler steel compositions that could be produced quickly and in enormous quantities. Welding techniques were crude by Western standards, but they were fast and efficient. Imperfections were accepted as long as the armor performed adequately in combat. This philosophy prioritized quantity and functionality over cosmetic perfection. The T-34's armor proved devastatingly effective during the middle years of the war. German crews were often shocked when their shells bounced off the sloped frontal plates. This forced Germany to upgrade guns, develop new ammunition, and redesign tanks entirely. In this sense, Soviet armor did not just protect tanks, it reshaped the enemy's strategy. Heavy tanks followed a similar philosophy, though with different priorities. The KV-1 featured thick armor designed to absorb punishment directly. Early in the war, its armor was nearly immune to standard German anti-tank guns. However, this protection came with drawbacks. The KV-1 was heavy, slow, and mechanically unreliable. Its armor protected it from fire, but its lack of mobility often left it isolated or immobilized. As the war progressed, Soviet designers learned from these limitations. They began to balance armor, thickness, slope, and mobility more carefully. Later, heavy tanks such as the IS-2 combined sloped armor with substantial thickness, creating vehicles capable of both surviving enemy fire and delivering devastating attacks against German heavy tanks and fortifications. Another defining characteristic of Soviet armor was its tolerance for damage. Soviet tanks were designed with the expectation that they would be hit, damaged, and continue fighting. Armor plates were thick enough to resist penetration, but not so brittle that they shattered catastrophically. Internal layouts, while Spartan, allowed crews to survive impacts that might have destroyed more complex vehicles. Industrial resilience played a crucial role in Soviet armor success. Factories were relocated eastward beyond the reach of German bombers. Production lines were simplified relentlessly. Armor designs were standardized to reduce variation and speed assembly. This allowed the Soviet Union to produce thousands of armored vehicles even while under constant attack. Armor that could be produced quickly became more valuable than armor that was theoretically superior but slow to manufacture. Soviet tank armor was also shaped by the expectation of mass combat. Tanks were not intended to operate alone. They were part of vast armored formations supported by infantry, artillery, and later air power. Armor needed to be good enough to survive long enough to fulfill its role within this system. Absolute invulnerability was neither expected nor required. The effectiveness of Soviet armor became increasingly apparent as the war turned in the Red Army's favor. German guns that once dominated the battlefield struggled to keep pace with evolving Soviet designs. Each increase in German firepower was met with further refinements in armor layout, thickness, or production methods. This cycle favored the side with greater industrial capacity. And in that context, Soviet armor design proved remarkably resilient. Understanding Soviet tank armor requires shifting perspective. It was not designed to win individual duels through superiority alone. It was designed to win a war of attrition. Sloped armor, simplified steel production, and acceptance of imperfections allowed the Soviet Union to field armored forces on a scale that Germany could not match. By the middle of the war, Soviet armor had achieved a balance that few other nations managed. It offered meaningful protection, allowed for rapid production, and supported large-scale offensive operations. This combination transformed armored warfare and laid the foundation for post-war tank design around the world. Soviet tank armor in World War II was therefore not merely a technical solution, it was a strategic weapon. It reflected a deep understanding of the relationship between industry, battlefield reality, and long-term sustainability, in a conflict defined by scale and endurance. Soviet armor proved that survivability was not just about thickness, but about adaptability and mass. As Soviet tank armor matured during the later years of World War II, its true strength became increasingly evident not in isolated technical comparisons, but in sustained battlefield performance. While German armor grew thicker and more complex, Soviet armor became more consistent, more reliable, and more closely aligned with the realities of industrial warfare. This difference would prove decisive. One of the most important factors behind Soviet armor effectiveness was material philosophy. Soviet steel was often less refined than German armor plate, but it was intentionally designed to be tougher rather than harder. This meant that when shells struck Soviet armor, penetration was not the only outcome engineers considered. Even when armor was compromised, it tended to deform rather than shatter. In the chaos of battle, this difference mattered enormously. Another key element was the interaction between armor and slope. Soviet engineers understood that sloped armor multiplied the effectiveness of every millimeter of steel. By combining moderate thickness with aggressive angling, they achieved protection levels that forced German designers into a constant race to increase gunpowder. This escalation favored the side that could adapt production faster, and Soviet factories proved remarkably capable of doing exactly that. The T-34's frontal armor remained a benchmark throughout much of the war, even as German guns improved. The combination of slope and steel quality ensured that frontal engagements were risky for German crews. This forced German tactics to rely more heavily on flanking maneuvers, ambushes, and specialized weapons. Soviet armor, therefore, did not merely protect tanks, it dictated enemy behavior on the battlefield. Heavy Soviet tanks followed a different but complementary path. The KV-1 demonstrated the power of raw thickness early in the war, but its mechanical shortcomings revealed the limits of that approach. Soviet designers learned from this experience. When the IS series emerged, particularly the IS-2, armor philosophy had evolved. Thick frontal plates were combined with slope, and overall design emphasized both protection and offensive capability. The IS-2 was not invincible, but it could withstand punishment long enough to break through fortified positions and engage German heavy armor effectively. Internal layout also contributed to the effectiveness of Soviet armor. Soviet tanks were famously cramped and uncomfortable, but their simplicity reduced the number of components that could fail under combat conditions. Armor plates were standardized across models wherever possible. Welding techniques were simplified, and tolerances were widened to allow faster assembly. Even when they destroyed Soviet tanks, replacements arrived quickly. Soviet armor did not need to be superior in every engagement. It needed to be good enough, often enough, for long enough. In this context, the balance Soviet engineers achieved between protection, production, and repair proved devastatingly effective. The later stages of the war demonstrated the maturity of Soviet armor philosophy. Design stabilized, production accelerated, and battlefield integration improved. While incremental improvements continued, the fundamental principles remained unchanged. Sloped armor, tough steel, and mass production formed the backbone of Soviet armored success. Soviet tank armor in World War II was therefore not about achieving technological dominance in isolation. It was about creating a system that could endure sustained conflict against a technologically advanced opponent. By aligning armor design with industrial capacity and strategic necessity, the Soviet Union transformed armor from a protective feature into a force multiplier. This approach reshaped armored warfare permanently. Post-war tank designs around the world adopted many of the principles pioneered or refined by Soviet engineers. The lessons learned on the Eastern Front would influence military thinking for decades, proving that effective armor is not measured solely by thickness, but by how well it fits into the broader machinery of war. By the final phase of World War II, Soviet tank armor had fully proven that its greatest strength was not dominance in isolated technical metrics, but durability within a complete system of war. The Red Army no longer relied on individual tanks to outperform their enemies through sheer protection alone. Instead, Soviet armor functioned as one component of a massive, integrated force designed to absorb losses, maintain momentum, and overwhelm the enemy through sustained pressure. Late-war Soviet armor development reflected confidence rather than desperation. Unlike Germany, which was forced into increasingly complex and resource-intensive designs, Soviet engineers refined what already worked. Armor layouts were adjusted, production techniques improved, and quality control stabilized. There was no need for radical reinvention. The fundamental principles of sloped armor, tough steel, and standardized production had already delivered strategic success. The IS-2 heavy tank symbolized the maturity of Soviet armor philosophy. Its frontal armor combined substantial thickness with slope, providing meaningful protection against German heavy guns while remaining producible at scale. More importantly, the IS-2 was designed to fulfill a specific battlefield role, breaking through fortified positions and engaging enemy heavy armor at decisive moments. Its armor did not aim to make it invulnerable, but resilient enough to complete its mission within a broader offensive operation. At the same time, medium tanks like the T-34 continued to form the backbone of Soviet armored forces. Incremental armor improvements enhanced survivability, but the core design remained unchanged. This continuity allowed production to continue at extraordinary rates. Factories delivered thousands of tanks with predictable armor performance, ensuring that armored units could be replenished faster than they were destroyed. One of the defining advantages of Soviet armor was its relationship with logistics. Armor designs were intentionally compatible with Soviet transportation networks, repair capabilities, and industrial limitations. Tanks could be shipped by rail, repaired in forward workshops, and returned to service with minimal delay. Armor that could be maintained under harsh conditions proved far more valuable than armor that required specialized facilities. Allied and German observers alike noted the resilience of Soviet armored units in late-war operations. Even after sustaining heavy losses, Soviet formations reappeared rapidly, rebuilt and reinforced. Armor that enabled tanks to survive damage, be repaired, and fight again multiplied the effective strength of the Red Army. This regenerative capacity overwhelmed opponents who relied on smaller numbers of highly specialized vehicles. Anti-tank guns grew larger, ammunition more powerful, and tactics more aggressive. Yet this escalation did not fundamentally alter the balance. Psychologically, Soviet tank crews operated with a different understanding of armor than their German counterparts. Armor was trusted to provide reasonable protection, but survival was expected to come from coordination, movement, and numbers rather than invincibility. This mindset encouraged aggressive action. Crews advanced knowing that losses were part of the system, not a sign of failure. Armor was a tool, not a shield against reality. By contrast, German armor had become a symbol burdened with unrealistic expectations. Tanks were expected to dominate individually, to survive overwhelming odds, and to compensate for strategic disadvantages. Soviet armor carried no such burden. It existed to support a doctrine built on mass, momentum, and relentless pressure. This difference in expectation shaped outcomes as much as any technical specification. The success of Soviet armor also influenced post-war military thinking across the world. The emphasis on sloped armor, standardized production, and battlefield repairability became foundational principles in modern tank design. Nations recognized that armor must be evaluated within the context of how wars are actually fought, not how they are imagined in isolation. In retrospect, Soviet tank armor achieved something few military technologies managed to accomplish. It aligned engineering decisions with national strategy, industrial capacity, and battlefield reality. Armor thickness was sufficient, slope maximized effectiveness, and production methods ensured continuity. There was no wasted effort chasing unattainable perfection. The Eastern Front demonstrated that armor effectiveness is measured over time, not in isolated encounters. Soviet tanks might be destroyed in large numbers, but they returned in even greater numbers. Armor that supports endurance ultimately outperforms armor designed for superiority alone. Soviet tank armor in World War II therefore represents one of the most successful examples of military engineering aligned with strategic necessity. It was not the thickest, nor the most refined, nor the most comfortable, but it was the most appropriate for the war being fought. In a conflict defined by scale, attrition, and industrial power, Soviet armor proved decisive. Understanding this legacy requires moving beyond comparisons of millimeters and penetration charts. Soviet armor succeeded because it was part of a system that valued sustainability over spectacle. It accepted damage, absorbed losses, and continued forward. That relentless continuity, more than any single technical innovation, explains why Soviet armored forces played such a central role in the defeat of Nazi Germany. In the end, Soviet tank armor was not just steel shaped into plates. It was an expression of strategy made material. It embodied the understanding that wars are won not by isolated machines, but by systems that can endure pressure longer than their enemies. That lesson, forged in steel on the Eastern Front, continues to define armored warfare to this day.